For the rest of this unit, we pulled Chapter 11, Section 6 in because it also talks about solving systems of linear equations. So it tags on to solving for the systems by graphing, but now we're going to use the equations and solve by substitution. So our essential question is, how do I use substitution to identify a solution for a system of equations? Remember, a system of equations is a set of two or more equations that contain two or more variables. A solution of a system of equations is a set of values that are solutions of all of the equations. If the system has two variables, the solutions can be written as ordered pairs. When solving a system of equations, remember to find values for all of the variables. To solve a general system of two equations with two variables, you can solve an equation for x or for y and plug it into the other equation. This is called solving by substitution. So let's solve the system of equations. Looking at both equations, we have an easy setup for solving the first one for y or the second one for x. Let's start by taking the second one and solving for x. So in order to do that, we would add 3y to both sides. So on the right-hand side, we get x equals 11 plus 3y. Now what we do is we take what x equals, just as if it were a number, and we substitute it into the other equation for x. So it becomes 5 times the quantity 11 plus 3y plus y equals 7. What we've done is we've replaced the variable x in the first equation with what we solved x to equal in the second equation. From here, we use distributive property to get 55 plus 15y plus y equals 7. We combine any like terms we have, so 15y plus y is 16y. From here we solve for y, so we would subtract 55 from both sides and get 16y equals negative 48. Carrying that over, we then divide by 16 to both sides, and we get y equals negative 3. The caution earlier told us to remember to solve for both variables. So we have the y variable, now we need the x, or the y value, excuse me. So we'll take either equation. It's easiest to take the one that we have x equals, and we plug negative 3 in for y. So we get x plus negative 9, or 11 plus negative 9 equals 2 for x. So our solution is the ordered pair 2, comma, negative 3. Relating this back to what we did with graphing, if we were to graph those two equations, they would intersect at the point 2, negative 3. You can solve for either variable. It's usually easiest to solve for a variable that has a coefficient of 1. So let's try another one. Looking at the equation on the left, both the variables have something with them as a coefficient greater than 1 or less than 1. So maybe we want to take the equation on the right and solve for x. So we could add 5y to both sides, giving us 4 plus 5y. And now we replace x in the first equation with 4 plus 5y. So we get negative 2, parentheses, 4 plus 5y, plus 10y equals negative 8. We start by distributing the negative 2 to get negative 8 minus 10y plus 10y equals negative 8. Next we combine the negative 10y and the positive 10y, which is 0. So we get negative 8 equals negative 8. Well, what kind of answer is that? That's a true answer, so the system of equations has an infinite number of solutions. This means if we were to graph these two equations, they would be the exact same line, and they would have an infinite number of solutions. Let's try another one. X plus y equals 5, 3x plus y equals negative 1. You could choose either one of these to solve, so let's just take the first one and solve for y this time. So we subtract x from both sides to get y equals 5 minus x. That means in the second equation we'll be replacing y with 5 minus x. We start with this in parentheses because if that was a minus instead of a plus after the 3x, we would have to distribute the negative through. So just to make sure we do things accurately, we always start with it in parentheses. Since there is no negative there, it's just 3x plus 5 minus x equals negative 1. Combine the 3x minus 1x for 2x plus 5 equals negative 1. Subtract 5 from both sides. So we get 2x equals negative 6. Sorry, it's cut off a little bit there. From there we divide by 2, and x equals negative 3. We're not done because we need the y value. So we take one of our equations. We'll take y equals 5 minus x. Substitute negative 3 in there. So 5 minus the negative 3 equals 5 plus 3, which equals positive 8. So we would write our solution as an ordered pair. X is negative 3, y is 8. That's it. Make sure your notes are filled out. We'll do some more practice in class. And write down any questions you have and be sure to ask them when you get a chance.